So just over the holidays, I finished a bathroom renovation. Pretty happy with the way it's come up. One of the things we installed was underfloor heating. So under here there's an electric element, and that element comes on and keeps the floor nice and warm. But I am a bit of a Captain Planet, and I'm a bit worried that this luxury is going to use a lot of electricity, cost us money, and produce more CO2 than we need to be producing. So I'm on my way down to Bunnings to pick up some underfloor insulation, and we'll do a bit of an experiment to see whether it is actually going to save money and save electricity and reduce emissions. So here we are under the floor, and part way through, just putting it up in there. It's not a particularly fun job, so shout out to the apprentice plumbers. Kudos to you, well done. So like I said, I'm a bit of a Captain Planet. This is an energy monitoring app that comes with the solar. So we're going to try and get some evidence to work out whether installing insulation is actually making any difference. So if we have a look down the bottom here, this goes back to the 21st of this month, and in red is all of the energy that is being consumed from the grid. We're going to look specifically at this time period between midnight and 6 a.m, 6:30, because that's the period of time when most things are off, and we can pick out which appliance is using energy. So if we have a look at this graph, these peaks are when the floor heating comes on. The floor heating uses 600 watts. We know that from the box, from the install, when we calculated how big it needs to be. So these peaks that come on and off are 600 watts. And I also checked, I can see when the thermostat for the floor clicks on, the consumption goes up by 600 watts. These other little parts down here, that long flat one, I know is the fridge. And then those little bumpy ones down the bottom there, that's like background standby use for the modem, the TV, that kind of thing. But what we can do is look at, in the past, on the 21st, our power went up around 12:35 and then dropped down again about 12:45. The next time it clicked on was at about 1:40, 1:35, 1:40, and off again by 1:55. And we can see that pattern follows along all the way up until this one here. This is another odd-shaped one, but this is the time when the thermostat changes from 20 degrees to 25 degrees. So this is a heat up time. You can see the heat up time starts at 5:45 and goes until about 6:25. Let's skip ahead. Let's compare that to today. So we get a different looking graph. We have the same pattern. The reason it looks different is because it's only recording up until 8 a.m. And the vertical axis is different. So it's actually recording the same thing. The power goes up by the same amount, up to there 684. But what we can do to compare our previous usage to the current usage, or the usage post insulation, is by going through that same process, by adding that time when it turns on, about 12:30 until the time when it turns off, 12:50. Again, 1:35 to 1:50, and so on. And that pattern's repeated. The pattern looks pretty similar. And again, you've got this heat up period, 5:55 to 6:25, when the heater changes temperature from 20 degrees to 25 degrees. So your task is to, one, calculate how much energy we used before, and two, calculate the new energy use, determine if there's a difference, if it's going up or down, if there's a trend, and then work out how long it will take to pay back the investment